Okay, so we've got a shape here that is involving triangles, a right angle, two lengths. So it looks like it's a question that's involving well, two lengths with a right angle triangle, Pythagoras, a length and an angle, and a right angle triangle, then trigonometry using sine or cosine or tangent functions. And then we've got a triangle over here which looks like it's going to be any old triangle with an angle here, and once we find this length we'll have two lengths. And we've got a side angle, side triangle, which looks like we're going to be using the cosine rule. So it's a nice question, got lots of bits in it, so let's get on. So if we go for this triangle here, we can see that two lengths are given. We need this length here, so it's going to be Pythagoras. And again, my advice always is write down the rules you're using so that you can identify what you need with their little pictures to remind you that the hypotenuse is labelled C for Pythagoras, and then the A and the B could be any of the other two short sides. So for working out the length of CB, then it's going to equal, so CB squared plus, because CB is a short side, CB squared plus 3 squared is going to equal 8 squared. And so CB squared plus 9 equals 64. So CB squared is equal to 73. So CB is worth as root of 73. At this stage, that's only an intermediate answer. It's not the final answer because the question wants the length of CD. So we would leave it in surd form so that we've got the exact answer for that particular length. We can add that onto the picture though. Again, advice would be always add things onto the picture as you find new information because it may help you to do the rest of the question. So what we look at now is we can see that this right angle triangle has a length and an angle, which means we can use one of the sine, cosine or tangent functions to allow us to calculate the length of CD, which is actually what the question wanted. So this is going to be our theta, the angle that we're working with. This will be then the opposite side of that angle. And we need this side here, the length of CD, which will be the hypotenuse of the right angle triangle CBD. So when we go through the usual way of remembering which function we're going to use, a lot of people use SO, car, TOA, sine, cosine and tangent, and we go through identifying what we know. We know the opposite length, so we can tick under the O's. And what do we need? We need the hypotenuse, so we can tick under the H's. What we notice is that this function here, the sine function, we've got two of the bits of information we need to find the third one. So we use the sine function. So let's calculate the length of CD then. We're going to say that the sine of theta is equal to the opposite length divided by the hypotenuse length from the SOHCAHTOA. And we identify the information we know. So theta is 50 degrees, O is the root of 73, and H is our question mark. It's what we need to find. So we notice that what we need to find is actually on the bottom of a fraction in the denominator position. So we need to rearrange this just to get it to be H equals, because we're trying to find the value of H. So divide by H, to move the H then we'll do the opposite of that operation, which will be timesing. So we're going to times by H, which would give us H times the sine of theta is equal to O. We want the value of H, so the sine theta is in the wrong place. It's in the place where H is. We need it over here. So instead of times we're going to divide. So we find that the answer we want comes from finding the opposite length divided by the sine of the function. So H is equal to the root of 73 divided by the sine of 50 degrees. So we get our calculator, we make sure it's in degrees mode, and we put that in. So the root of 73 divided by the sine of 50 equals, so 11.153, which equals 11.2 to 3 significant figures. Okay, because we recognise the question when we look back at it, it says 3 significant figures. So that's a quick reminder of the use of Pythagoras and your sine, cosine and tangent functions in right angle triangles through recognising bits that we need. So it's the usual thing about what do we know, what do we need to know, and we go through the process of writing down the rules. The next part of the question goes on and says we want the length of CE, which is this length here, and what we notice is that this is a right angle we've got 50 degrees so far, so we know a right angle is 90 degrees, so we recognise that this angle is 40 degrees. We worked out the length of CD, so we can now add that onto the picture, and 11.153, and more than 3 snippet figures, because we want the answer to be 3 snippet figures, so the accuracy just slightly bigger than that to start with, and then we'll be able to round at the end. So when we look at this triangle, then we can see that we've got a side trapping an angle between another side. Now when you have side angle side triangles, then the rule that you can use is the cosine rule when it's not a right angle. If it's a right angle, there are slightly easier ways of using the sine function, the cosine function, or the tangent functions, but when it's a triangle without a right angle in it, then quite often it's about using the appropriate cosine rule or sine rule to work out missing lengths and angles. In this case we want a missing length. We notice we've got a side angle side triangle, and that implies the cosine rule could be used. Now the cosine rule suggests that if you've got a triangle labelled A, B, C with capital letters for where the vertices are, in other words where the angles are positioned, and then opposite those is the smaller case letters for the lengths, and it's the opposite letter, so for capital A, opposite little a, and so forth. And the rule says that the length of A squared is going to be equal to the length of B squared plus the length of C squared, take away 2BC cos of big A. So in other words, if the angle was there, then we'd be able to label it because it's side angle side. So because the angle we're dealing with is here, then I'm going to ignore the letters of the question. I'm just going to work through that. That's where the angle is, and that's where my A is. So this is going to be my number here. So for me, I'm identifying that capital A is worth 40 degrees. That's where the angle is. The two side lengths are those two, which means that little b is going to be worth 11.153, and little c is going to be worth 19. So I've identified the information I need according to the rule by writing the rule down, recognising how it works, working with the triangle that they gave us to decide what each of the variables were worth. I can now come down to the actual space for the answer for this question, and I can work it through. So just to remind us, the rule was to get the length of A squared. It's going to be the length of little b squared plus the length of little c squared, take away 2bc cos of big A, the angle. When we look back at the picture then, the angle was 40 degrees, so we're going to say cos 40 degrees. The length of B was 11.153, so 11.153 squared. The length of C was 19 squared, and we're taking away twice 11.153 times 19. Okay, so we're going to put that in our calculator and find out what we get from that. So we have 11.153 squared plus 19 squared, take away bracket 2 times 11.153 times 19 times the cos of 40 degrees, close the bracket, equals. Now I put a bracket around the 2 times bit just to make sure it all happens as I need it to. Some calculators you don't need that, it'll automatically recognise under the order of bid mass what's going on. But for this question, I've covered myself by putting the bracket there. So 729. So that's the value of A squared, but obviously the question wants the length of A, so we have to square root this. So the square root of that number is 12.67. So A is equal to the square root of that, which is equal to 12.6778. Because the question wants the answer to 3 significant figures, then 1, 2, 3, always find your first non-zero digit and count along 3 times. So 1, 2, 3, that means we're cutting the number there, so we're going to round to this digit here, so the 7 will change the 6 up by 1 because it's more than halfway up in the tenths column. So we're going to go 12.7 centimetres. Okay, so that's a quick reminder then about how you can use the rules involving triangles, angles, lengths from using Pythagoras trigonometry to using the cosine rule. I mean, the key to it all, guys, is learn your rules, write the rules down, identify the values of each of the letters, put them into the formulas, the rules, and work it through. Just being careful on your rearranging and checking whether these answers actually seem reasonable. So that's an example to follow, guys.